In your calculator, you would enter in 64 raised to the power of 1/3 over, and then times 64 to the power of 2/3. And then when you press enter, you should get 64. So just carefully enter those, making sure you're in the exponents and then out of the exponents, and you'll be good. So now for 6.4 notes, operations with radicals and solving radical equations. First part is just simplifying radical expressions. So in those first two blanks, when adding or subtracting radicals, you will need like radicals. Like radicals. And steps to addition or subtraction of radicals. First, you simplify each radical. Then be sure to multiply each by their coefficients. And then combine like radicals or like terms. Either one would work there. Keeping radicals the same. So you can check your answers in your calculator and find the decimal equivalent, just like we did with the opener. You could have just used your calculator, and be sure to use parentheses in appropriate places. So for number 1, 6 radical 3 plus 2 radical 3, all of the steps are done except for step 3. We just combine the like radicals. So since those are already the same, we're going to end up with 6 plus 2, which is 8 radical 3. So 8 radical 3. Number 2, you can see that we have 2 like radicals, radical 5, and then we have an unlike radical, the radical 7. So we're going to combine our like radicals. 3 and 2 is 5. The radical 5 stays the same. And just like we would do with algebraic expressions, we cannot combine these two because the radicals are not like radicals. Number 3, cube root of 9 and cube root of 9, those are our 2 like radicals. We can't simplify that further, so we'll combine the 6 minus the 2 and get 4 cube root of 9. You probably do the next one on your own. We're just doing the same process. Again, we have like radicals. When there's not a coefficient there, we could throw 1 in. So negative 8 minus 1 is negative 9, 4th root of 3. That part stays the same. We're just combining like radicals. On number 5 is where things start to change up because we don't have a simplified radical. We have a simplified radical here. Square root of 8, these should start to look familiar. Square root of 8 has a perfect square factor of 4. So we're going to write this as 3 radical 4 radical 2. So this is not a new process of simplifying radicals. We can square root 4, we can simplify that. That would be 2, so 3 times 2 is 6. Bring down our first term, which was 6 radical 2. The sign stays the same. 6 radical 2 minus 6 radical 2 is 0. So that's your final answer. Number 6, the 2 is simplified. The radical 50 has a perfect square factor of 25. And so the square root of 25 is 5. So we have 3 times 5, or 15 radical 2. Bring down that first term, 5 radical 2. Sign stays the same. 5 radical 2 minus 15 radical 2 is negative 10 radical 2. 7, we have 2 radicals to simplify this time, the 12 and the 27. Square root of 12 can be simplified into the square root of 4 and the square root of 3. I usually write my perfect square first. I mixed them up. I'm going to do one at a time here, though. Square root of 4 is 2, so we could write that as negative 6 times 2 radical 3, or negative 12 radical 3. 27 can be split. We have a perfect square factor of 9. So we write that as radical 9, radical 3. Square root of 9 is 3, so 4 times 3 is 12. So we bring down the sign, same sign. Negative 12 radical 3 plus 12 radical 3 is 0 again. Number 8. First one's already simplified. The 12 gets simplified again. Some of them we see frequently enough that you start to have them memorized. Square root of 12 can be simplified into radical 4, radical 3. So that's going to be a 4 times 2 radical 3 or an 8 radical 3. Bring down the first term, so 6 radical 3. Sign stays the same. So we have 6 radical 3 minus 8 radical 3. Negative 2 radical 3. Number 9. We're going to simplify the 18. I see a perfect square factor there of 9. Square root of 9 is 3. So we have 12 radical 2. Square root of 50 we just did, so that's a 25. Split that into 25 and 2. Square root of 25 is 5. Keep the sign the same, the operation the same. So 12 minus 10 is 2, radical 2. Last one. There are 3 terms in this one, but it's okay. Put a little star next to it. It's not that bad. We're going to simplify each one. We've already seen 12. We know that one simplifies into... Zach?
You want to give the answer?
Oh, not yet. Hold on one second. Radical 4, radical 3.
Yeah.
Okay, can you just walk us through it then?
That's not my hand.
Oh, okay. Go ahead. So 6 radical 3, yeah? Then what'd you do with the next term here?
Oh, I didn't do that when I was
Oh. So then the radical 27, that splits into 9 and 3. If you stick with this process, you'll avoid some simple mistakes. So just writing it out. It doesn't take a ton of time to write it out, but it does probably help you avoid some common mistakes. And then we've got the minus radical 48. So that's the square root of 16 times the square root of 3. Again, we're looking for a perfect square factor. The largest perfect square factor that would go in there. So that's going to be a minus 4 radical 3. Then when we combine like terms, 6 and 18 is 24, minus 4 is 20. So our final answer would be 20 radical 3. Number 11 is sort of a transition question. So read carefully and rewrite the equation, filling in the given information, and then simplify. You're going to approximate your answer. So I want rounded to the nearest whole number. Find the approximate period of the pendulum with length 622.